great question. 17.11, question 7. I'm going to do this in two parts actually, because there's a bit of explanation that needs to come first, I think. So here's the equation: x squared plus 8x plus p is equal to 0. So if we were to factorize this, by the way, and we've got a p on the end, so we don't know what the full factorization is going to be. But if we were to say, let's factorize this first bit, and we were to say this is equal 0. We're going to ignore the p bit for a moment. This is going to be x, and x plus 8 is equal to 0. I'm going to ignore this. This is still there, but I'm going to ignore it, yeah? So let's just draw that up just for a moment, yeah? So here it is. We've got our y and our x. Here's our 0. And we know that x is going to have to, if this is true, then either this x is going to be 0, or this x here is going to have to be -8. So that's going to be a 0, it's going to be a -8, yeah? Here's my 0, here's my -8. And so the parabola is actually going to look something like, and I'll try and draw this as best I can, it's going to look something like that, yeah? And it's going to head up that way and head up that way. And that's roughly what the parabola is going to look like. And at the moment, it's got two unequal roots. They're unequal. Look, one's -8 and one's 0. And they're real, as in they're real numbers. This -8's a real number and 0 is a real number. By the way, if we were to move it up, in other words, we were to introduce a p-value here that actually increased the value of this, because that p-value here is responsible for moving it up and down. So if I moved it up this far, so it was halfway in between there, and it looked like this now, yeah, then suddenly it would have moved up so many units, and this point here now is going to be, well, halfway in between, and now we actually have an equation for this line here. We know this is going to be y is going to be x plus 4 all squared, yeah? So we've got x plus 4 all squared. In other words, x is going to be equal to -4 or -4. It does it twice. In other words, now the roots are real and they're equal. Sorry, you can't see that. They're real and they're equal. In other words, it's the same root twice. But what say we increase p even more here? In other words, it moved even further up and it was like this. So it's no longer touching the x-axis. Now the roots are going to be no longer real. And they're certainly not equal or unequal. They're not even real. They're not even there, because it doesn't touch the x-axis. We only have roots when the graph touches the x-axis. So that's really what that p-value is doing. It's that at the end there, it's moving the graph up and down. And what this question's asking is, if it's going to be real and equal, it can't go any higher than here, and it's going to have to just be slightly lower. It's going to have to be like there. So it's got two unequal roots. Here it's got two equal roots, but, sorry, it's out of focus. Got in focus, thank you. Here, it's equal roots, slightly unequal, more, and so on, yeah? So that's what the question's really asking. So what we're wanting to do is the more we move up p, the more it's going to run into the risk of being above the axis, and of course then we've got imaginary roots. So that's what that p-value does. And the question simply asking is, what's the range of values? What range of values would p have to be if this was to be true? In other words, if it was to be in fact, if it was to be lower than that line there, that line where it touches. That's what the question's asking. And in the next video, I'll show you how we calculate precisely that.